This webcast continues the discussion of the review of the unbalanced force model. And so I'm going through the problem set that we have as review for this unit. I'm on problem 3. So we have a situation where a truck its engine is pushing it to the right with a force of 7,000 newtons. I'm going to just notice that I have a prefix here. I'm going to have to interpret that kilo in the weight of the truck here. It says the friction force between the ground and the truck is 5,500 newtons, and the air resistance causes a drag force of 1,000 newtons. A 200 kilogram crate is sitting in the bed of the truck. Okay, so I need to do a force diagram for the truck. Okay, so they're giving me the weight of the truck. Okay, so the gravitational force on the truck is 15 kilonewtons. That's the same thing as 15 times 10 to the third, or 15,000 newtons. The engine is applying a force on the truck to move it toward the right, and that has a value of 7,000 newtons. The friction force is opposing the motion, and they're telling me that that has a value of 5,500 newtons. And there is some air resistance, so drag force on the truck by the air is 1,000 newtons. Now the truck is being supported by the ground, so there's a normal force on the truck by the ground. Because the truck is not moving vertically, it's not levitating, it's not sinking into the ground, the net force in the vertical direction should be 0, because there's no motion in that vertical direction, and that should equal, oh, wait a minute, I have left something out. Let me go back and, so what I've said is correct, but I left out the fact that there is a 200 kilogram crate sitting in the back of the truck. So the crate is actually pressing down on the truck, right? I'm going to call this an applied force. I think properly it would be a normal force, but just since I already have a normal force in this vertical direction, I'll call it an applied force on the truck by the crate. And I need to calculate that. The mass of the crate is 200 kilograms. So the amount of this force would be the 200 kilograms times 9.8, which would be 1,960 newtons. Okay, now I'm ready to write this equation for the net force in the vertical direction. The normal force, that support force from the ground, is pulling upward. So I add that one. But then I have two forces that are pulling the truck down. I need to subtract both of those. One is that applied force that the crate is exerting, and one is the gravitational force that the earth is exerting. Okay, and then I want to find the value of this, which is 0. Okay, so the net force there is 0. All those three forces add up to 0. Then it says find the amount of the normal force that the ground exerts on the truck. So the normal force must be the sum of the applied force by the crate and the gravitational force. So it would be the 1960 plus the 15,000. One way to think of this is that because the truck is at equilibrium in the vertical direction, there has to be as much force pulling the truck up as there is pulling it down. Okay, so that normal force would be 16,960 newtons. And I'm going to come up here to my force diagram and just add that value in. Okay. Then they ask us to find the net force in the horizontal direction. Okay, so I've got three forces in the horizontal direction, right? There's the truck, the applied force by the engine, the friction force, and the drag force. And so the applied force pulls the truck to the right, so I add that one, but then I have to subtract the friction force and the drag force. I have values for all three of those forces, and so I can plug those in here and calculate that net force. Uh-oh, I wrote something down wrong. It was 5,500. And so actually, I get a positive 500, right? So there's 500 newtons of net force pulling the truck to the right. So what is the acceleration of the truck? Here I'm going to use Newton's second law, that the acceleration equals the net force divided by the mass. Well, I know that the net force is 500 newtons. Do I know the mass of the truck? Let's go look. I don't yet. They gave me the weight of the truck as 15 kilonewtons. So that means that the mass of the truck would be that 15,000 newtons divided by 9.8. And that would be 1530.612 kilograms. And so I've got that amount of mass of the truck, but the total mass that is accelerating it's going to be not only the truck, but also the crate, because the crate is riding in the truck. And so it would be the mass of the truck plus the mass of the crate. Okay, so it would be that 1530.612 kilograms plus the crate has a mass of 200 kilograms. So I need to add both of those together, and that gives me 1730. Okay, that's the mass that I'm going to use here to find the acceleration. And so I get an acceleration of 0.289 meters per second squared. Okay. Then it asked me, if the truck was initially at rest, how much time would it take to reach a speed of 25 meters per second? Okay, this sounds like a kinematic equation. It's asking me, to find time given the initial and final velocity. So it says it was initially at rest, and so I know that the initial velocity was 0. It sounds like the final velocity is 25 meters per second. We just found the acceleration is 0.289, and we're looking for the amount of time. So that's my question mark. So I need a kinematic equation that involves all four of these variables. Happily, the first equation works, and it's happy because, the math for this equation is very easy to use, right? And I'm going to be solving for that elapsed time. So the elapsed time here is going to be the final velocity minus the initial velocity divided by the acceleration. So I have 25 minus 0 divided by that 0.289. And so it's going to take 86.505 seconds for it to reach that speed. Okay, let's look at the next one. Noel is diving into a deep quarry lake from a 10-meter high cliff. So she's on this tall cliff, here's the water, and she's going to dive in. So we'd like to know her speed just as she enters the water. Okay, so let's see. Is this going to be a kinematic equation or is this a Newton's second law? Let's write down what we know. I know her mass is 62 kilograms. I know that her displacement going from the top of the cliff down to the water is going to be negative 10 meters, right? She's moving in the negative direction. I can probably safely assume that her initial velocity is 0. And she's in free fall as she falls down, so her acceleration will be negative 9.8 meters per second squared. And I'm looking for the final velocity. Okay, so I think I'm finding that I need a kinematic equation in this situation, right? I could find, I suppose, the net force on her, but that's just going to be her weight since she's in free fall. That's not helpful. What will be more helpful is to find a kinematic equation and solve for the final velocity. The one I'm going to have to use is the third equation, right? Vf squared equals the initial velocity squared plus 2 times the acceleration times the displacement, and I'm going to be solving for this final velocity. So that'll be 0 squared plus 2 times negative 9.8 times negative 10. And so the final velocity is going to be the square root of 196. Don't forget to take the square root, which would be negative 14 meters per second. The negative is because she is moving in the negative direction. Okay, in part B, it says, okay, the drag force on Noelle is 688 newtons. How far will she move under the water until she stops? So now we're looking, okay, she's entered the water and she moves a little distance before, I don't know, I can't sketch, but she moves about some distance before she comes to a stop. Okay, so again, I know now as she entered the water, that's her initial velocity here. So that's negative 14 meters per second. She's coming to a stop, so her final velocity is 0. Let's see, I don't know her acceleration. Wow, those are the only things. What I'd like to find is her displacement. Okay, but they're telling me the drag force. So let me think about the forces on her when she's in the water. Her weight is a force that's pulling her down. So that would be, you know, her mass times 9.8. That's the gravitational force that the Earth is exerting on her. And that is 607.6 newtons. And they're telling me that the drag force, this is the drag force on Noelle by the water, is 688 newtons. So I could use Newton, or I could find the net force and say it's going to be the drag minus the gravitational force. So 688 minus that 607.6. The net force is going to be 80.4 newtons. With that net force, I can find the acceleration, because that is the net force divided by her mass, which was 62. Okay, so her acceleration is 1.297. Okay, now if I add that to the things that I know, I have enough information to use a kinematic equation to solve for the displacement. And so I would have to use this equation, Vf squared equals Vi squared plus 2 times the acceleration times the displacement. This time I'm solving for the displacement. Let me go ahead and shift my equation around. Displacement would be Vf squared minus Vi squared divided by 2 times the acceleration. And let's see, the acceleration was 1.297. If I look at this negative sign cancels, right? Because negative 14 times negative 14 is a positive number. But my other negative sign, there's nothing to cancel it, so I should get a negative displacement. And when I do the math, I get 75.559 meters. She goes quite a distance before she stops.